Hello, everybody. This paper is about dualistic wave. It is a proposed explanation of Zeno's paradox. Basically, it uses the this limit to solve Zeno's paradox. This is abstract. In this paper, a novel geometric object named dualistic wave is established and employed to solve the dilemma of Zeno's paradox. In one period, a dualistic wave is composed of four curved infinitesimal line segments, and each of them is equivalent to a flat infinitesimal line segment. A dualistic wave can be viewed as an infinitely small wavelike space or an infinitely small flat space. They are equivalent. Intuitively, the ingredient of a straight line is obviously an infinitesimal straight line segment. However, it is shown that the ingredient can also be viewed as an infinitesimal curved line segment. An infinitesimal line segment is classified into two categories: flat infinitesimal line segment and curved infinitesimal line segment. The equivalence between a flat infinitesimal line segment and a curved infinitesimal line segment is demonstrated. This is based on the concept of equivalent infinitesimal in calculus. For example, this limit sin x over x approach 0. This limit is equal to 1, and this limit indicates that the curved infinitesimal line segment described by the equation y equals sin x is equivalent to the flat infinitesimal line segment described by the equation y equals x. Here is about flat and curved infinitesimal line segments. In Cartesian coordinate, the mathematical equation y equals x represents a straight line. A straight line is flat, so the equation y equals x is between 0 and an infinitesimal, represents a flat infinitesimal line segment. And the mathematical equation y equals sin x represents a wave. A wave is curved, so the equation y equals sin x is between 0 and an infinitesimal, represents a curved infinitesimal line segment. There are many curved infinitesimal line segments, such as y equals tan x is between 0 and an infinitesimal, and y equals log x plus 1, x is between 0 and an infinitesimal. This is about how to construct a dualistic wave based on equivalent infinitesimals. Generally speaking, if y equals fx is a nonlinear function, and this nonlinear function satisfies this limit, then we can use the function y equals fx to construct a dualistic wave. And this figure shows this idea. Nonlinear function y equals fx is a mathematical representation of a wavelike motion, and y equals x is a mathematical representation of a particle-like motion. It is a straight line, and as the scale is infinitely small, and fx is equal to x, so in infinitely small scale, wave-like motion is equal to particle-like motion. And this shows how to construct a dualistic wave based on this limit sin x over x as x approaches 0. This is based on the equivalence of the curved line segment y equals sin x. X is between 0 and infinitesimal, and the infinitely small straight line segment y equals x. X is between 0 and infinitesimal. This shows the dualistic wave constructed by using the limit sin x over x as x approaches 0. And in this figure, we can see that in one period, a dualistic wave is composed of 4 infinitesimal line segments, OA, AB, BC, and CD. And the line segments OA and AB are symmetric about the straight line AE. And the curved infinitesimal line segments BC and CD are symmetric about the straight line CF. And here is a system of equations describing the dualistic wave. Here is a transformation of coordinates by rotation, and we rotate the dualistic wave by 45 degrees. And we do transformation of coordinates according to this formula. And then we have the dualistic wave viewed by the observer in the line y equals x. And this is the system of equations describing the dualistic wave. And here we can see there are 4 equations. And the first equation describes the curved infinitesimal line segment OA. And the second equation describes the line segment AB. And the third equation describes BC. And the fourth equation describes CD. Here it shows the solution to Zeno's paradox based on dualistic wave. This figure shows that Achilles travels along dualistic wave path, and the tortoise travels along a straight line path. In figure above, it is seen that we assume Achilles runs along a dualistic wave path. It's like this. It's curved path. And it is possible that Achilles overtakes the tortoise without passing the points the tortoise took previously. The underlying mechanism of its explanation is the equivalence of flat and curved spacetime at infinitely small scales. Here the conclusion is that the classification of infinitesimal line segments, including flat and curved infinitesimal line segments, is proposed. A novel type of geometric object named dualistic wave is given, and it serves as a mathematical tool to reveal the equivalence between wavelike and particle-like motions at infinitely small scale. And the duality of the space-time structure at infinitely small scale is demonstrated by dualistic wave, and it provides a solution to Zeno's paradox. Thank you.